All right, let's talk about one of the big ones in object-oriented programming, the Singleton pattern. It's one of those patterns that everyone seems to have an opinion on. So in this explainer, we're going to cut through the noise, figure out what it is, why it's so handy, and most importantly, how to use it right in your own code.
So let's just jump right into the core problem this whole thing is trying to solve. Imagine you're coding away and you have a class that, for whatever reason, you need to make sure has one and only one instance running, ever, across the whole application. How on earth do you enforce that? It's a super common challenge, and it's the exact reason the Singleton pattern even exists. To make this less abstract, let's look at a real-world scenario that pretty much every developer has run into: managing your app's configuration settings. So picture this. You've got a class. We'll call it Configuration Manager. Its job is super simple. Go read some settings from a file, maybe a database, and then hand those settings out to any part of the application that asks. You'd want every part of your app to be reading from the same set of configs, the same single source of truth, right? Of course you would.
Okay, now let's say one module in your code needs the database connection string. What does it do? Well, naturally, it creates an instance of the configuration manager. Seems harmless enough, it gets the setting it needs, and life is good. But then, a little later, a completely different part of your app, maybe the logging service, needs to know where to write its log files. So it does the exact same thing. It creates its own brand new instance of Configuration Manager. Uh-oh. Now we have config1 and config2 floating around. You can probably see the storm clouds gathering, can't you?
And bam, here's what happens. You've got multiple instances that might be totally out of sync. What if one of them reloads the config file but the other doesn't? Chaos. You're also just wasting memory and resources creating these duplicate objects, which is a big deal if they're expensive to set up. And worst of all, that single source of truth we wanted? Yeah, that's gone. The whole thing becomes a nightmare to manage.
So how do we fix this mess? Well, this is precisely where the Singleton pattern comes riding in to save the day. It offers a really clean, elegant way to stop this from ever happening.
The core idea is incredibly simple, but also incredibly powerful. Just think of that classic line from the movie Highlander. There can be only one. That's it. That's the entire philosophy of the Singleton pattern in a nutshell. It enforces that rule on any class you want.
Now, if we want to get all formal about it, the textbook definition calls it a creational pattern, but what that really means is that it does two very specific jobs. First, it absolutely guarantees that a class will have one and only one instance. And second, it gives you a single global door to knock on to get access to that instance.
So how does it pull off this magic trick? It all comes down to a simple 3-ingredient recipe. First, you lock the front door by making the constructor private. That stops anyone from just creating a new instance whenever they feel like it. Second, the class itself secretly holds onto its one and only instance in a private static field. And third, it gives everyone a special key, a public static property, usually just called instance, that they have to use to get the object.
Okay, enough with the theory. It's great and all, but let's see what this actually looks like in practice. Let's see how this pattern solves our configuration manager problem with actual code. And here it is, the aha moment. Just look at the difference. On the left, you've got the Wild West, new instances being created all over the place. But on the right, you've got the Singleton solution. It's so clean. No matter where you are in the code, you just ask for configurationmanager.instance, and every single time you get the exact same object back.
Simple, controlled, and totally predictable. Problem solved.
Now, before you run off and turn every class you've ever written into a singleton, we need to have a serious talk. Because like any powerful tool, it's not a silver bullet. It comes with its own trade-offs, and it's absolutely crucial to understand both the good and the bad.
So let's break it down. The benefits are pretty sweet. You get guaranteed controlled access, a single global place to find your object, and it's often lazy, which means the object isn't even created until the first time you ask for it. But the drawbacks can be a real pain. A singleton is basically a global variable in a fancy code, which can make your code harder to test and create sneaky dependencies. It creates tight coupling, tangling your other classes directly to it. And in a multi-threaded app, oh man, you have to be really careful or you can run into some nasty concurrency bugs.
You might be thinking, hey, what about other patterns, like the factory pattern? Well, factories are great for making new objects, but they couldn't care less about limiting how many you create. And the prototype pattern? Its whole job is to clone objects, which is literally the exact opposite of what we want here. Nope. When the job is to guarantee one and only one instance, the singleton is the specialized tool for the job.
So, keeping all of that in mind, the good, the bad, and the ugly, when is it actually a good idea to pull the singleton out of your toolbox?
You should really only consider it for a few classic cases. Things like a centralized logging service, where you need every part of the app to write to the same place. It's also great for managing really expensive objects, like a database connection pool, where you definitely don't want to create new ones all the time. And finally, it's a solid choice for managing some kind of shared state that has to stay consistent across your entire application.
And that leaves us with the big question, doesn't it? Is the singleton a powerful, essential tool for keeping things under control, or is it just an anti-pattern, a ticking time bomb waiting to make a global mess of your code? The real answer, like with so many things in programming, is it depends. Used wisely, in the right context, it's brilliant. Used carelessly, it will absolutely cause you headaches down the road. The key is knowing when to use it, and maybe more importantly, when not to.